Like before, let's assume that x is normal, then x bar is also normal. Now you have seen the three-number rule and you have used it in chapter 15 homework also. So this diagram, you have seen that in chapter 15 homework. So this diagram shows that 95% of all sample means live within +2 and -2 standard deviations from mu. Now let's make sure that we understand how this diagram is related to the Z diagram, the standard normal density curve. So this mark mu +2 standard deviations, what does that correspond to on the Z axis? So let's use some numbers. For example, let's say mu is 10, 1 standard deviation. So remember, we are dealing with sample means now. So 1 standard deviation means 1 sigma divided by square root of n. So let's assume this is 0.3. So 2 standard deviations is 0.6. Mu plus 2 standard deviations is 10 plus 6. Sorry, 10 plus 0.6. 10 plus, I'm sorry, 10.6. So this is 10.6, and this is 10. Now, so what is this Z value that corresponds to 10.6? So we use this formula. So let's rework the numbers again. So x bar, 10.6, mu, 10, divided by 0.3. This is 0.6 divided by 0.3. This is 2. So this mark, mu plus 2 standard deviations, correspond to the Z value of 2. And the other mark, mu minus 2 times the standard deviations, corresponds to -2. And it should make sense because Z is the number of standard deviations x bar is from the center mu. So these numbers, +1, -1, +2, -2, +3, -3, these are all just Z scores. These are just all Z values. Another concept that we want to pay attention to in the three-number rule is the concept of neighborhood. So this distance between -2 standard deviations and +2 standard deviations, we can informally call this a neighborhood of mu. So how big is this neighborhood? We can say this neighborhood is roughly 2 standard deviations big. On the east side, 2 standard deviations, and west side 2 standard deviations of mu. And how many sample means live in this neighborhood? Well, we say roughly 95%. So let's look at another diagram. It's a simpler one without the density curve. Okay, so this is mu. This is +2 standard deviations, -2 standard deviations. So this is the neighborhood of mu. Let's say we repeat our study 100 times. So we have 100 sample means. According to the three-number rule, how many sample means, roughly speaking, live in this +2, -2 neighborhood? So roughly speaking, 95 sample means live in this neighborhood. So most of the sample means live in this neighborhood. How many live outside the neighborhood? Roughly speaking, if we repeat our study 100 times, roughly, probably 5 of them, just a small number of sample means live outside this neighborhood. Okay, so this is the concept of neighborhood. It's an informal concept that we should focus on now from the 3-number rule. Let's dig deeper of this concept of neighborhood. Let's do it one more time. Let's say we repeat our study 100 times. And we have this plus 2 minus 2 standard deviations neighborhood. So roughly, a lot more, so on and so forth. So out of 100 times of our studies, roughly 95 sample means lie within this plus 2 minus 2 neighborhood, and approximately a small number, let's say just 5 sample means lie outside. Let's pick, let's say, the sample mean. Okay, let's take a look. So this is, let's say, this is my sample mean. Now let's assume that I, Olivia, has long arms, but retractable long arms. So if I stand right underneath this spot, this mark, this location of my sample mean, let's assume that I can extend my arms as long as or as short as I want. So this length, you can look at this length is roughly, this blue segment of my arm is roughly 1 standard deviation long, right? So I'm going to do an operation to extend my arms 2 standard deviations long. So let me do that to the other side. Okay, so that's me. I'm standing right at the mark of my standard deviation. And I extend my arm. So this is my standard deviation, X bar. I'm standing right underneath it. I extend my arms each side how long? 2 standard deviations long. Well, now, the good news is, because my arms are so long, you can see that I can capture the mu. Mu is within my reach. So because I'm in this plus 2 minus 2 neighborhood, I stand underneath, I stand at the mark of my sample mean. So I have my own neighborhood, right? This is my own neighborhood. This is my plus 2 minus 2. Then mu falls in within my neighborhood. Okay? Let's take a look at another one. Let's say this time, this is my sample mean. Okay, so this time I just move the, let's see if I can do that easily. Okay. So this is a bit crowded, so I'm going to get rid of this old diagram and get rid of all these. Just bear with me. It's not super easy to move. Okay, let me just remove one at a time. So I'm standing here, and then I extend my arm again. In each direction, how long do I extend my arms? 2 standard deviations long. Then you can tell that I can capture mu also. I'm in that 2 plus 2 negative 2 standard deviation neighborhood of mu. And that means when I extend my arms plus 2 and minus 2 standard deviations long, I can capture the mu. So as long as I am within the neighborhood of mu, I can capture mu. Now, but if I'm outside, let's say if my sample mean is here, outside the neighborhood of mu, then you can see what the consequence will be. So I'm here now. So let me see if I drag all this, faster. Now, I have a sample mean x bar here, which is outside the neighborhood. When that happens, if I stand underneath this, stand at the mark of that sample mean, I extend my arms still plus 2 or minus 2 standard deviations. So I have my own neighborhood. But this time, unfortunately, mu is too far. Mu is out of my neighborhood. Okay? Why? Because my sample mean is out of the neighborhood of mu to begin with. And that means even if I extend my arms, I cannot capture mu. So the point is, if I'm in the neighborhood of mu, then mu is in my neighborhood. It's a reciprocal concept, right? Neighborhood. If I'm close to mu, mu is close to me. If I'm close to mu, meaning if my sample mean is in the neighborhood of mu, then mu is in my neighborhood. Then mu is within the reach of my sample mean. Well, in more detail, it means that mu lies within the plus 2 and minus 2 standard deviations of my sample mean. Now you know that how often can I capture the mu? Well, not every time. If my sample mean is too far away from mu to begin with, I cannot capture mu. So how often can I capture mu? 95% of the time. So if my sample mean is so unlucky that it's so far from mu, outside the neighborhood, then mu is too far. Mu will be here, and I cannot, so there's a gap here. There's a gap here. I cannot capture mu.